Today we're going to be talking about section 4.3, and it's on solving by factoring. Now this is something we looked at in quadratic algebra, but we're coming back to it and we're going to solve some equations by factoring. And all of these, we're going to have a leading coefficient in 1. So in section 4.3, we're going to have a leading coefficient of 1, and we're going to be solving by factoring. So the first thing we're going to talk about are a couple of terms. Monomial is an expression that is either a number, a variable, or a product of a number and one or more variables. So some examples would be like the number 3. That's a monomial. Mono means one. Nomial is number, so it's one number. So 3 would be an example. X would be example. That's our variable. And a product of a number or a variable, we would have something like 4x squared y. That is also a monomial. So all three of those are types of monomials. A binomial is the sum or a difference of two monomials. So x minus 3 is a monomial. And 3y plus 4 is also a binomial. Okay, so those are two examples of binomials. And it could be something as complicated as 3x squared minus 4/5 w cubed z to the 5th. That would also be a binomial because we have two terms. 3x squared is a term, and then all of that last part is a term as well. And then a trinomial obviously is the sum or difference of three monomials. So most common, we're going to look at something like x squared plus 2x plus 7. So we're just going to have three terms now. So looking at the review of the FOIL method, and this is just multiplying two binomials. You can use the distributive property. We can use the FOIL method. Either way, it's going to be the same thing. So if we do the FOIL method the first, we're going to do x times x, which is x squared, outsides minus 3x, insides plus 4x, and then the last is negative 12, and then you add your like terms. So essentially what we did is we took these two binomials, we multiplied them together, and our answer now became a trinomial because we have like terms. Well, when we look at factoring, we're really just going the opposite direction. We're going to take our trinomial today and we are going to factor. To factor means we're going to break it down in its factors. Like if we factor the number 6, the factors of 6 are really 2 times 3. So when we do that, that is factoring the number 6. So we're going to do the same thing with our trinomials. Now, when we look at how to factor, the first term, the x squared term, is going to come from the product of the first term in each binomial. And then the last term is going to come from the product of the last two terms. And then the middle term comes from those middle two terms added together. So if we look here, m plus n must be equal to b, and the product of m and n must be c. So here's what we're going to do. We're going to start by looking at one of these. So we're going to take our x squared. Well, what are the factors that give us x squared? Well, it has to be x times x. Next, we're going to look at 48. What are the factors of 48? Well, we have 1 and 48, 2 and 24, 4 and 12, 6 and 8, 3 and 16. So we have to figure out which ones are going to get us to the middle of 14. So the numbers that we wrote down here are the ones that we're going to put in. So we need to get them to add up to 14. And obviously these are the ones that are going to work. So we're going to have 6 and 8. And in this case, if this is a plus sign, that means both these signs are going to be the same. And in this case, since their first one is positive, then they're both going to be positive. And you can always double check to make sure you did it correct. If you FOIL this, you're going to get x squared plus 8x plus 6x plus 48. Does that give us back to our original? And the answer is yes. So here is our answer in factored form. The next one. Again, the first term has to come from the products of x squared. So that's going to be x and x. The next one, the last terms have to come from the product of 5. Well, this is an easy one. 5 only has 2 factors, and those are 1 and 5. So this has to be 1 and 5. Now in this case, we see that this sign is negative. Well, that tells us that one of these is going to be positive and one of them is going to be negative. So if we make this one negative and this one positive, that's going to give us x squared minus 5x plus x minus 5. Does that give us back to our original? No. That gives us a negative 4x in the middle. So what we're going to have to do is switch those signs around. So let's try to switch those signs to a plus and a minus. Well, all that's going to do, let's go the other way. So if we switch those signs, a minus and a plus, now what that's going to do is give us x squared plus 5x minus 1x minus 5. And does that give us back to our original equation? No. So in this case, we can see that this problem is not going to factor. Okay, there are no other possibilities, so this one will not factor. All right, so quickly, go ahead and try to factor questions 1, 2, and 3. You can pause the video, hit play when you're ready. So there are the answers to questions 1, 2, and 3. Notice they have opposite signs in number 1 because the 18 is negative, so we have to have one of each. The second one can't be factored because both signs have to be the same, and then in this case they would both be negative, so I tried n minus 3. That's not going to work. We could also try 9 and 1, but that's not going to work either, so this one can't be factored. And number 2 or 3, we have different signs, and we'll have r plus 9 and r minus 7. The next thing we're going to talk about is the difference of two squares. Now, these are special factoring patterns, so the difference of two squares in a perfect square trinomial. Now, if you don't see that these trinomials or in the difference of squares of binomial are set up this way, that's fine. You can just factor them as normal. So the first one says if we have a perfect square minus a perfect square, then when we factor it, we're going to get a minus b and a plus b. Notice everything is the same about those two binomials except for one is going to be positive and one is going to be negative. So we have x squared minus 9, we're going to have x minus 3, x plus 3. In the perfect square trinomial, this one is the first term is a perfect square, the second term is a perfect square. So we're going to have a parenthesis squared, and then whatever this first term is, if it's a plus, that sign will be a plus. If it's a minus, that sign will be a minus. So let's look at a couple examples like that. First, we're going to look, is this perfect square? Yes. Is this perfect square? Yes. So right away I'm going m, 11, m, and 11, because 11 times 11 is 121. And I'm going to go plus and minus. Now, the reason that we use this is what's going to happen to our middle terms. Well, if I FOIL this, it's m squared minus 11m plus 11m minus 121. So here in our middle terms, what's going to happen? They're going to cancel out. So that's why we have a binomial in this case. So our answer is m plus 11, m minus 11. In B, I notice this is a perfect square and this is a perfect square. So in this case, I'm going to go R and then 9. Nope, 7. 7 squared is 49. So 7. And then we look here, and this is a positive sign, so that we know that this is what our answer is going to be. Now, if you didn't see that, you would factor it. You would have R plus 7 times R plus 7. And those are the same thing. But if you see that pattern, that's what you would have. And you can always check it by foiling it. Now, there's a shortcut to foiling it. We really don't have to check the firsts and the lasts, because that's how we got the factors that we're putting in here, R and 7. So if I take these two terms, R plus 7, well, R times 7 is 7R, and then I do it again, R plus 7 is 7R, that's 14R, and that gets me to my number so that I know I did that right. Next one, perfect square, minus sign this time. So I know this is going to be P minus 12. And if you take these and check it, it will work, because that's negative 12P, double it, because we have two of them, so that's negative 24P, and so there's your answer. All right, so go ahead and pause the video, and you can check questions 4 through 7 quickly. And here are the answers to questions 4, 5, 6, and 7. Now the next thing we're talking about are the roots, and these are the solutions to a quadratic equation. So we've solved lots of equations linear, and now we're going to be talking about quadratics. So we're going to talk about the zero product property, and what that says is if the product of two equations is 0, then one or both of the expressions must equal 0. So if A and B are expression, and we know that A times B equals 0, then either A has to equal 0 or B has to equal 0. Because the only way that we can get an answer of 0 is when we multiply those two numbers, is if one of them is 0. So here, if x plus 5 times x plus 2 equals 0, then either x plus 5 has to equal 0 or x plus 2 has to equal 0. So if x plus 5 equals 0, well then we know that x equals negative 5. If x plus 2 equals 0, then we know that x has to be negative 2. So in example 3, they ask us to find the roots of the equation. So it says, what are the roots of the equation? X squared minus 5x minus 36. Well, here's what we're going to do. We're going to factor this. So let's take this. Factors of x squared are x. Factors of 36 are 1 and 36. That's not going to work. We have to get to 5. So we want to find all the factors of 36, and then we want to find the ones that are 5 apart. Well, that's going to be 9 and 4. Okay. We look at this sign, that's negative, which tells us that we're going to have one positive and one negative, and the bigger one is going to be negative. So we can check it by checking the outsides and the insides. Okay, so if I check the outsides and the insides, I don't have to check the first, because that's how I got my x times x. I don't have to check the last, because that's 9 and 4. So let's check the outsides and the insides, and that gives us 4x minus 9x. Well, does that give us negative 5x? And the answer is yes. So this is our factor. So I have x minus 9 times x plus 4 equals 0. So that tells us that either x minus 9 has to equal 0 or x plus 4 has to equal 0. Because one of those two has to be 0 if we're going to get an answer of 0. So if I add 9 to both sides in this one, it's 9. If I subtract 4 from both sides in this one, it's negative 4. So my answers are 9 and negative 4. So it is C. All right, so it says if an equation of the form x squared plus bx plus c equals 0 with c is less than 0. So that means if we take this last term and we see that this last term is negative, okay, if it can be solved by factoring, what do we know about the signs of the roots? Well, we know that the signs will be opposites. Because if that number is negative, we know that we have to have one of each. Because that's the only way we can get a negative product is if we take a negative number times a positive number. Two positives will give us a positive, and two negatives will give us a negative. The second bulleted statement here says if an equation of the form x squared plus bx plus c equals 0 has only one root, what kind of trinomial is x squared plus bx plus c? Well, the only ones that we saw that are only going to have one root are will be if this is a perfect square trinomial. And the reason is because if we look back up here, when we get to a problem like this one, if we set that equal to 0, you're only going to have one answer. Because we'll have y plus 8 equals 0 or y plus 8 equals 0. Well, that's going to result in the same thing. So we're only going to have one solution if that is a perfect square trinomial. Next, example 4 says you have a rectangular vegetable garden in your backyard that measures 15 feet by 10 feet. You want to double the area. Okay, so it's going to be 15 feet by 10 feet. You're going to double the area of the garden by adding the same distance x to the length and width of the garden. Find the value of x and the new dimensions of the garden. So essentially, what you're going to do is you're going to make a new garden. Well, actually, let's do this a different way. We're going to add the same dimension. We're going to call this from here to here x, and from here to here x. So we're going to add the same distance to the length and to the width. So if we look at that, what is our new dimensions going to be? Well, the old length was 15 feet. So now what would that one be? Well, it's going to be x feet longer, so it's going to be 15 plus x. And the width was 10 feet, and now it's going to be x feet longer, so it's going to be x plus 10. We know that the old area was 150 feet squared. So here it says we want to double the area. So now instead of 150 feet squared, this is going to become 300 feet squared. So now we have our equation set up. And from here, what we're going to do is we're going to FOIL it, and then we're going to have to go back the other way and factor it. So we're going to have 150 plus 15x plus 10x plus x squared. I'm going to put it in standard form. And I'm going to do a couple steps here all at once. 0 equals x squared plus 25x. And then we're going to subtract that over. So it's going to be minus 150. Right? So here is our quadratic. So now what we're going to do is we're going to come over here and we're going to factor this. Well, obviously our first term has to be x and x. And we now have to find the factors of 150 that are 25 apart. So what are factors of 150 that are 25 apart? And those factors are going to be 5 and 30. We notice here that the signs are different. So I want the bigger one to be positive, so it's going to be plus 30 and minus 5. So now we set these equal to 0. X minus 5 equals 0, or x plus 30 equals 0, which means that x is going to equal 5, or x is going to equal negative 30. Now, if we think about this a second, which one of these is going to be our answer? Well, obviously, it has to be x equals 5. We can't add a negative distance to the dimensions of our garden. So find the value of x. It's right here. And the new dimensions of the garden. So the garden will now be 15, it was 15 by 10, so now it's going to be 20 by 15. So it's going to be 20 feet by 15 feet because we are adding the same dimension to both sides. Okay. So and we're going to skip the guided practice question for, well, we'll do number 8. Well, we'll just do this one quickly. X and X, 6 and 7, minus and plus. And so X is going to equal -6 and X is going to equal 7. So here are the answers to number 8. Now, if we go down to question number, or example 5, it says find the zeros of a quadratic function. Well, finding the zeros of a function is the same essentially as finding the solutions. So if they give this to us in y equals, now we're just really putting this equation in intercept form. Well, remember, intercept form is y equals a times x minus p times x minus q. So essentially, what are we going to do with this? We're going to factor it. And so the only thing we have to do to this problem is to factor it. So it's x and x. Factors of 28 are 7 and 4, the ones that are 3 apart anyway, so we're going to have a plus and a minus. So now it's in intercept form. Well, remember what we know from intercept form. What are my intercepts? -7 and 4. So that's going to tell us where the zeros are because the y equals 0 on the graph at that point. So the zeros are at -7 and 4. Now we could set that equal to 0 from right there and factor and solve it just like we had before. Same thing for B. We're going to factor this. So it's going to be x and x. Factors of 4. Plus 4. So factors of 4 are 2 and 2. That's what we're going to have to use. And the signs are the same. And they're both going to be negative. So it's going to be minus and minus. So in this case, we're only going to have one 0, which is at 2. So in this case, the 0 is at x equals 2. And the same thing, we could set, once you have it factored, you could go 0 equals, x minus 2 times x minus 2, and set both those equal to 0, and we're going to get x equals 2, like we did over there. Okay. So go ahead and try questions 10 and 11, and then pause the video, and you can hit play when you are finished. All right, and there are the results for questions 10, 11, and 12. Your homework assignment for page 255, or for section 4.3 is on page 255. So remember, today the things that we talked about is we're talking about solving quadratic equations. So we're looking at factoring, and then once we have it factored, we're looking at finding what the zeros are, which is the same thing as the solution. So if you see directions or anything that says find the solutions or find the zeros of your quadratic equation, you're really finding the same thing, only you're looking at one from a standpoint of they're just giving you the numbers and it equals 0, and they're looking at one in a form that it's going to be given to you in well, standard form, and then we put it into intercept form.